Hello. For these two problems from Chapter 7, you want to use the Excel file. And it says the amount of syrup that people put on their pancakes is normally distributed with a mean of 58 and a standard deviation of 12. Suppose that the 50 randomly selected people are observed pouring syrup on their pancakes. Round all answers 4 decimal places. So for the first one, this is a distribution about x, one single value. And so this is your mean and your standard deviation, which were 58 and 12. Now when you're doing, notice this has x with a line over it, so an average, more than one, like for part D, a group of 50, then your mean is still the same, 58, but the standard deviation, if we come over here, it's equals the 12, the original standard deviation, divided by, and then type SQ because we want square root of n, and n was 50. So it's your standard deviation divided by the square root of 50, because that's our sample size. And we round 4 decimal places, 1.6971. Now, for the next part, if a single randomly selected individual is observed, find the probability that this person consumes between 58.1 and 59.2. So if we want the percent between, when you find the percent at the 59.2, that gives you the percent from this 59 and below. But we want between. So if we find the 59.2 and then subtract the percent below 58.1, it will give us what's between them. Okay, so first we'll find the 59.2. I'm going to click here, put equals, and start to type normal. Now, we want percent, so you use normal distribution. If you have the percent and you're finding the number, you use normal inverse. So we want normal distribution and double click it. Then it tells you what you need. You need the x value, which was 59.2, comma. Now this was a single randomly selected individual, so you use part A, 58 and 12. You put commas between them, and then cumulative under the curve is 1, so it's always 1. And hit enter. So 53.9, or do they want the percent? No, they want the decimal. So 0.5398, that's below the 59. We need to do the same thing for the 58. So we type norm, whoops, don't forget your equal sign, equals norm, and we want normal distribution. Then we put our number, 58.1, comma, this was the single one still, so 58, comma, 12, comma, 1, and hit enter. So below 58.1 is 0.5. For the value between them, you subtract it. So we would put equals, and we'll click on the first one. Then you can put a minus sign and click on the second one and hit enter, and there's your answer. 0.0365. We need to do the same thing for this one, except the standard deviation, because this is for the group of 50 pancake eaters. So you use part B. You use 58 and the 1.6971. Now what you could do is click on the first one, because the numbers are the same, 59.2, and we just need to change the 12 to a 1.6971. 1.6971. And hit enter. Then we'll do the same thing here. Change that 12 to a 1.6971. 6971. And it's already subtracted them for us. And there's your, oops, I didn't click on it. And there's your answer. Is the assumption that distribution is normal necessary? No. It's not necessary because your sample size is over 30. It was 50. Okay, so this one would be the same, but we'll go over it. Let me delete what we have. Okay. What is the distribution? Well, this is the capital X is for a single one, so it is the mean and standard deviation that is given, which was 15 and 6. So it's 15 and 6. For a sample, and our sample is 16, it's still the 15, but then to get the standard deviation, we'll come over here, we'll put equals, the standard deviation, 6, divided by, and then we want square root of n, which is 16, and hit enter. Whoops, what did I forget? Oh, I didn't close the parenthesis. Okay. So it closed the parenthesis for me. But equals 6 divided by the square root of 16, 1.5. And that's how they got the 1.5. Again, this one is in between. What is the probability that a randomly selected person drinks between 14.5 and 16.5 ounces of coffee a day? And this is one randomly selected person, so it's part A. We'll put equals norm distribution. And if you forget, it tells you what to put. X, which was 16.5, comma, the mean 15, standard deviation 6, cumulative 1, and hit enter. We do the same thing, equals norm distribution, and then we put 14 point, oops, sorry, I hit something. 14.5, comma, I don't know why that popped up, but 15, comma, 6, comma, 1, and hit enter. So this is below the 1, this is the other. We subtract them and we find the amount in between. Equals, and we can click on A2 minus A3, and there's our answer. The second one, because it's the sample of 16, you use the other standard deviation. So we could go here and click on it. We can change the standard deviation, which was 6, and make it 1.5. Go to the other one where the 6 is, put 1.5. And there's our answer, 0.4719. Is the assumption to this distribution normal necessary? Yes, it is. It's necessary because our sample size was smaller than 30. Since it was only 16, you need to assume normal. When we're finding the quartiles, the quartiles, let me get up. You have data, and there's, it's called a 5-number summary. You have your smallest number. Oh, there it is. And then, let me go. So we have 25% of the data, another 25%, okay. Now, right, the first one is our smallest number. But then if we go to the next one, this is the lower quartile. And then the median. And then the upper quartile. So if we want to find the lower quartile, when you're finding these, you want the percent below. Well, below the lower quartile is 25% of the data. So to find QL, it's 25% is below it. There we go. So for the first one, Q1, oh, they use Q1. QL is the same as Q1. And this is Q3. Some stats classes use QL and QU for lower and upper. They use Q1 and 3. 2 is your median. Okay. Now these other ones, we use the normal distribution. Let's see, what do we need? Q1. 25% below. So put equals and start to type norm. But this time we're looking for the number because we know the percent's 25%. So we use this one, the inverse. Then you put your probability as a decimal, so 0.25, comma, your mean, which was 15, comma, the standard deviation. And for the standard deviation, this says the average of the 16 coffee drinkers. So we're using B's, 1.5. 13.9883. Now Q3, if we look back at my drawing, is here. Notice the percent that's below it. 25, 50, 75. 75% of the data is below Q3. So when we find Q3, we go equals norm, and we want the inverse because we have the percent. Instead of 25, it's 75% of the data that's below it, comma, the mean, which was 15, comma, this was the sample of 16, so it uses the standard deviation from B, which was 1.5, and hit enter. And that's this one. The interquartile range is just subtracting these two. So we can put equals and click on the Q3 minus, click on the other one and hit enter. and you've subtracted them.